Welcome to lesson 113. We are going to talk about synthetic division today. So this is what we are used to doing when we have to do polynomial division. And that's when we typically have an x term with a coefficient of 1. And we're going to divide this polynomial by this binomial. And we know the process. We say x goes into this number, we get a response, and then we multiply, and then we change the sign, okay, so we can subtract, so that then we can reduce it as we go, so we can get down to what's left, which is the remainder of 83. And then this becomes your answer. All right, so keep this in mind right here. I'm going to show you how to do synthetic division. So the first thing we need to do in order to do synthetic division is we're going to take the zero or the root of our divisor. And the way we do that, remember when we factor something, right? If we find it's a factor, we get x plus 3, and then whatever the other term is, yada, 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 equal to 0. Well, we know that this is going to be, this could possibly be equal to 0. So we say x plus 3 is equal to 0, and then we subtract 3 from both sides. We find that x is equal to negative 3. That's what we're going to do. This is called the zero or the root. So we're going to take the zero or the root of our divisor, which would be negative 3. And then we're going to take the coefficient of every term within this dividend. And we are going to write our coefficients here. So we have a coefficient of 1, a coefficient of 0, a coefficient of 1, a coefficient of 2, and then we have a coefficient of 1. How is that a coefficient? Well, remember, if this is x to the 4th, and we had to put a 0 in for x to the 3 because it wasn't present in our original polynomial. This is x squared, this is x to the 1. This would be x to the 0 because x to the 0 is 1. 1 times negative 1 is still negative 1. So you want to go from the highest degree of x to x to the 0 in descending order for your coefficients every single time. Then we're going to draw a line, and we're going to multiply whatever is on the second line to get the next answer. So let me show you. There's nothing on the second line for the first number, so we always bring the first number straight down. Always, always, always bring that first number straight down, okay? That's the first rule. Now we're going to multiply negative 3 times 1. We get a negative 3. Combine these, add these together. That's negative 3. Negative 3 times negative 3 is positive 9. So now we have a 10. Negative 3 times 10 is negative 30. So that's going to be a negative 28 when we combine them. Negative 3 times negative 28 is going to be a positive 84. So that's going to be an 83. Now, this started at x to the 4th. We're going to subtract an exponent from here. That's going to be x cubed minus 3x squared. We always descend our terms, our degree of our x, plus 10x squared minus 28x plus, and whatever this last number is, that's our remainder. So we put that over our divisor. Remember, we flip the sign and put it back the way it is as our divisor here. That is exactly the same thing that we have here. And it was much, much faster. And that, my dear students, is called synthetic division. Okay. Now, synthetic division has certain rules. For now, you're going to use the coefficient or the divisor when there's a coefficient of 1 with your x term. That's all we're using in this lesson on synthetic division. And that's what you'll use going forward. For now, let's just focus on that. Let's not worry about when we have a coefficient with the x. We're just learning it, and we're going to learn how to do it in the way that you'll need it for college algebra when you ever get there, or when you get there. Let's do a practice problem. All right, so let's clear the board and we'll try this out and see if it works. So here, okay, my computer is taking its own sweet time. All right, so first of all, we're going to look at this and we're going to evaluate it and rewrite it if we need to, and we need to. Our highest x term is x cubed, and then we have a negative 4x squared. We don't have an x by itself, so we're going to say plus 0 to the x plus 13. And then we also have to rearrange this one. So we want to say x minus 3. All right, so our 0 or our root would equal, x would equal positive 3, right? Because if this is equal to 0, then that's going to be a positive 3. So that's what we need to do. So we're going to start with putting the 3 as our factor here. And now we're going to write our coefficients. We have a 1, we have a negative 4, we have a 0, and we have a 13. Okay, that's third, second, first, 0. Now we're going to draw our line, bring down our first term, and multiply. 3 times 1 is 3. That's negative 1. 3 times negative 1 is negative 3. That's negative 3. 3 times negative 3 is negative 9, and that would be 4. So now we write our answer, which would be x, one less degree than we started with. So x squared minus x minus 3 plus 4 over x minus 3. That is our answer. And that was so much faster than putting it in the other way. Okay, that is how you will do synthetic division. Let's do one more. We can do it right here. All right, so first of all, let's get our root. X plus 3, if that is equal to 0, then x is equal to negative 3. So that is our 0 or our root of the equation. So we're going to say negative 3, and then we are going to pull out our coefficients. So we have 2, x to the 3 is missing. So I'm going to put in a 0, then 1 for x squared, 2 for x to the 1, and then I have a negative 1 as my final term. Draw my line, bring down my 2. Negative 3 times 2 is negative 6. That's negative 6. Negative 3 times negative 6 is positive 18. That's 19. Negative 3 times 19 is going to be a negative 57. That would be negative 55. And negative 3 times negative 55 is a positive 165. So that's going to be 164. So now we just 1 degree less than we started. 2x cubed minus 6x squared plus 19x minus 55 plus 164 over x plus 3. And that is our answer. Okay, so I want to show you something. Let's do an example here of how this is a way that you can kind of check your work. So let's say we have this polynomial x squared plus 5x plus 6. We can turn that into a polynomial equation by just saying that it's equal to 0. So then we could actually factor this, right? So we could say x, and then this would be plus 3 and plus 2, right? So I can check that, make sure my factoring is right. I can see if that's a factor that works, right? I know it works because I factored the whole thing, but what if I didn't have the other factor? What if I was just given one of these? How would I check that? What if I was given x squared plus 5x plus 6 divided by x plus 3? Or what if I was asked if negative 3 is a root of this polynomial? What would that be? All right. Is negative 3 a root of this polynomial? Well, I factored it over here. So we already know ahead of time that it is, because x plus 3 equal to 0, right, would be x is equal to -3. So we know that -3 is a root because we factored it. So that's really what we're doing here, is we are factoring our polynomial. So all of the things that we have done to synthetically divide, we can say x plus 3 times the answer, or the quotient. We know that that would be the original polynomial, right? So we can illustrate that theory by doing this. All right, if the root is -3, then this would be x plus 3, right? So this divided by this, we can illustrate all of that. First, we take our root, which is going to be -3, and we would say -3, right? And then we have 1, 5, and 6. Bring the 1 straight down. -3. This is kind of just checking the synthetic division to show you that it really is real. -3 times 1 is -3. Combine those, we get a +2. -3 times 2 is 0. It is not 0. Miss Tracy cannot obviously multiply today. It is -6, which gives you 0. When you have a remainder of 0, right, then you know that this is going to be one of the factored roots of that problem. So you know by looking at it like this, that we're going to take this down to 1. That'd be x plus 2 would be your other factor. So you take this, x plus 3 times x plus 2, and that would equal x squared plus 5x plus 6. So you can kind of see how that works, how that goes together, and it's really kind of cool that you can back it out and go backwards and forwards with that, and all the rules apply. So we just proved synthetic division and how you can use it. All right, so let's do some more practice problems. Let me write it up here for us. So this question, this example problem is saying, is -2 a 0 of x to the 4th minus 2x3 plus 5x minus 10? So that means, is x plus 2 a factor? Is it a factor? So let's find out if it's a factor. So we're going to take -2, and we're going to rearrange these in the proper order. So x to the 4th, well, actually it is in the proper order. We're just missing 1. So we have x to the 4th, that's a 1. Then we have a -2 for x3. We don't have an x2, so we put 0 in. And then we have a 5 for the x and a -10 for x to the 0. Draw our line, bring down the first term. -2 times 1 is -2. That gives us a -4. -2 times -4, that's an 8. So 8. -2 times 8 is -16, so it's a -11. -2 times -11 is a +22. We have a remainder of 12. We can't have a remainder. We need to have a remainder of 0, 0 being the key word. So therefore, x plus 2 is not a factor. -2 is not a 0. That would be your answer. Not a 0. -2 is not a 0 of this polynomial, right? So that would be your answer. You would just type in no. That's all I'd want. That would be the answer. No. Is -2 a 0 of x to the 4th minus 2x cubed plus 5x minus 10? No. And we did that very quickly using synthetic division to check to see if it was a factor. Let's do one more. 113.4 says, is -3 a root of 2x to the 4th minus 32x equals 0? So, no, let's look and see. We have to do some things differently. No, we can't just answer it right off the bat. We have to do synthetic division. So we take our root or our 0, same thing, and let's set up our polynomial coefficients. So we have that's to the 4th. I don't see something to the 3rd. I don't see something to the second. We have negative 32 to the first, and we don't have anything to the 0. So if there's nothing to the 0, if there's not a whole number, you have to put a 0 in for it. That is what you've got to do. So now we're going to draw our line, bring down our number, our first term. Negative 3 times 2 is negative 6. Bring down our negative 6. That's going to be a positive 18. Bring down our 18. Negative 3 times 18 is going to be negative 54. We combine those and we get negative 86. Negative 3 times negative 86 is going to be 258. We combine those, we get 258. That's an 8. This whole term, that's our remainder. So the answer is no. It is not a root or a 0 of this polynomial equation because we have a remainder. So let's do one more that has the answer yes. Okay? And I just gave you the answer. What am I thinking? I want to show you a yes so you can say yes and know when that's appropriate. All right, so here is one that I found. I looked a couple lessons ahead and I found a problem. And it says, is 3 a 0 of x cubed minus 2x squared minus 9x plus 18? So let's see. So we know the division or the divisor here because this is a positive 3. Our divisor is going to be x minus 3 because if you set that equal to 0, x is equal to a positive 3, right? So it's always the opposite. So we're going to put positive 3 in here, and then we're going to pull down our coefficients 1, negative 2, negative 9, and 18. And now we're going to draw our line. We're going to bring down our first term. And now we multiply. 3 times 1 is 3. That's going to give us a positive 1. Again, 3 times 1 is 3. That gives us a negative 6. 3 times negative 6 is negative 18, and that gives us 0. So the answer here would be yes. Because we have a 0 remainder, we know that 3, or I should say x minus 3 is a factor of this polynomial. And then our factor, that would be factored like this: x minus 3 times x squared minus x minus 6. There is no remainder, so this goes away, and this is one of the factors there. So you can see how you can use that to help you factor longer polynomials. It's going to be a good method as you go forward to help you do the factoring of these longer things. And then once you can break out one of these, then this is easier, right? All right, so that is all we have for lesson 113. And I will see you in the next.